Okay, good morning. So today we're continuing talking about how operating systems work, and we're particularly focusing on what you need to do to manage files, what the operating system is responsible for, and what the user is responsible for. And the most important thing today is calculations to do with file sizes. So we want to understand how we can organize files into folders or directories. We want to construct an expression. Remember that phrase. It means we don't need to calculate it. We don't need to find the answer in numbers. We need to know how we would find the answer in terms of what we multiply or add together. We want to talk about permissions because that's all to do with security, and one of the most important jobs of an operating system is to keep things accessible but also secure. So we said that there are four main things that an operating system needs to be able to manage. Process means programs. So loading a process, sharing resources between processes, as in putting it into RAM and then taking it out of RAM if you've run out of RAM. File management is what we're focusing on today, getting people to log in and log out. And peripheral, that means like the actual hardware that you plug into it, so dealing with drivers and that kind of stuff. So when Year 7s arrive at Fulford, often they've only used an iPad before, and they just save everything without even thinking what it's called. So you end up with loads of files called thing or document one, and they're all just in one space. One of the most important things that we learn is organization. We are able to organize files and folders. Nowadays, it's become a bad habit to not really care about where things are stored. You just search for it and hope for the best. And some of you are still in that habit of storing all of your CT documents and all of your P documents just in your downloads. The operating system allows us to have one root place, like the root of a tree, and from that branches out all of the spaces where you can store your files. And you can have multiple files in multiple folders. Windows calls them folders, but really they are directories. And a subfolder is a subdirectory. There's a hierarchy because there's structure to it. The operating system is involved in abstraction. Remember, abstraction is hiding unnecessary detail to focus on the most important thing. What's the detail and what's the most important thing? Well, in this case, the detail is the bits and the bytes and the blocks and the sectors and the physical stuff that's going on inside your hard disk drive or your SSD. The important thing is the file itself, the name of the file, the path, as in the location through the folders of the file, and the contents of the file. But the operating system is responsible for dealing with that detail that we don't really care about at this moment in time. So you have a file system. Whenever you format a USB drive, you'll choose, is it FAT, is it FAT32 or NTFS or ext3 or something like that. And you can have a certain amount of bytes per sector. So that means even if you have a file that is just 1 byte, so the letter A, it's probably going to take up a certain amount of space, a minimum of 512 bytes, or up to maybe 64 kilobytes, even if it's only got 1 byte in it. Why? Because you allocate the space in terms of sectors. So we've come across this before. Remember, kick my granny too. We don't have to worry about pieces. We have these prefixes. You might be used to talking about kilobytes and megabytes, but in Edexcel GCSE computer science, we have this extra I because we're dealing with powers of 2, as in 2 to the power 10 is 1024. So in all of the questions you have in your GCSE, we'll deal with these units. So what does that mean? Well, if the hard disk has a block size of 512 bytes, that means it doesn't matter if you have 1 byte or 511 bytes. The amount of space it's going to take up on disk is going to be 512 bytes. You always have to round up. If a file is 2.8 kilobytes, then we're going to need to work out how much space it takes up or how many blocks. So 1 kilobyte is 1024 bytes. How many blocks? Well, 2.8 kilobytes, 2.8 times 1024, divided by the number of bytes per block, and that's our expression. We don't actually care about the answer. You're not expected to calculate it. If you were to calculate it, you get 5.6. You can't allocate 0.6 of a block on a hard disk or a solid state drive, so it's going to take up 6, we'll use the ceiling function, as in round up to the ceiling. So we're going to take 6 blocks. Here we go. Yeah, this notation here just means round up, but that's a bit unnecessary, so 6 blocks. I think do we really need to go through the rest of it just yet? I think it's worthwhile just making a start on this. Activity 1 for P20, you're going to need to open Windows Explorer and show like this is Windows 11, so it might look a little bit different, but it will still show a similar thing for you. If you find your files and folders and expand the folder structure in your computing folder so we can see all of the files and all of the folders, please. That's what activity 1 is after. And then you can practice some of these. I'll pause the video in a couple of minutes to go through 1 or 2 of these as examples. Okay, so we chose to go through activity 2, this third one together. We first of all need to know the formula involved here. So let's say number of blocks is going to be, so number of blocks needed is, or in fact, let's think of an easier way to do it. Total size is number of blocks multiplied by size of block. That makes sense, doesn't it? We might need to rearrange this. How many blocks are needed? So if we want number of blocks by itself, we're going to need to divide that by the size of the block. So that means I'm going to need to divide this side by the size of the block as well. So there we go. The number of blocks is the total size divided by the size of blocks. Let's plug the numbers in. So the total size is 1.2 gigabytes. What's a gigabyte? It's a capital B because it's a byte, not a bit. Well, first of all, it's 1.2 times 1024. Whenever you see this, remember, you always write down kick my granny to pieces, so we can remember the translations, the conversions. So this is going to take gigabytes to the next smallest one, megabytes. And then we also need to multiply by 1024 again to get it down to kilobytes. And then this is already in kilobytes. So let's just keep it all in kilobytes. So the size in blocks is just 1. Anything divided by 1 is 1, but I'm going to keep it in to show my marking, to show my working, sorry. And I don't need to work out the answer because this is an expression. If you want to find it out, you can do, but remember, you're not allowed a calculator in the exam, so you're not expected to do this, oh come on, in your head. But 1024 times 1024 times 1.2 and remember, you have to round up, so that's going to be all of that number but with a 2 instead of a 1. You're not expected to put the answer, you do have to say the expression. So we'll go through this one as well. A file is stored in 137 blocks. We've got the block size in bytes, and it says what's the maximum size of data in the file in kilobytes. So let's write out our things to remember. Kick my granny to pieces, kibby, mebby, gibby, tebby, and pebby. Then let's write out our formula. So total size is the block size multiplied by the number of blocks. That makes sense, doesn't it? Think about the total population of New York is the size of each block in New York multiplied by the number of blocks that you have. Makes sense? Then let's see if we need to rearrange. What are we trying to work out? The maximum size of data. Well, that's this, so we don't need to rearrange it. That's good. Let's plug the numbers in. Total size is equal to the block size in bytes, 2048. But we want this in kilobytes. So we might have to do some conversions at the end. So let's convert it all into bytes first. We have 137 blocks, so this will give us the total size in bytes. If we want to have the answer in kilobytes, we've just got to divide all of that by 1024 because we've gone from bytes to kibibytes. All right, whilst we're here, let's continue with the PowerPoint because I didn't go through all of it. So there are lots of different things you can do with a file. You can make a new one, you can write on top of it, you can change something that's already there, you can open it without viewing it, you can delete it, you can rename it. The operating system needs to track the permissions, so different users can have different permissions. And there are different levels of access. So a person might be able to view the contents but not change it. So say, for example, you walk into McDonald's, you can see the prices of a Big Mac, but you can't change the price of a Big Mac, unless you're the manager, in which case you're allowed to overwrite. I don't know if you are actually. Are managers able to change the prices in their stores? Don't know. Discussion for another day. Some files can be executed. An exe file can be executed, but a Word document can't be executed. It can be opened, but not executed. And you shouldn't be able to delete all files. Some are protected. So I don't really think we need to go through examples. I think this is fairly sensible. What you do need to do is work through the examples in here. So a local vet keeps all of its information. So we need to try and work out who has access. So a doctor, should they be able to see the financial information? Well, a general practitioner is self-employed, so arguably they should be able to see the accounts, but probably not able to write to the accounts, otherwise they can fiddle their expenses. Appointments, yeah, a doctor should definitely be able to read an appointment and write an appointment and probably delete an appointment. Patient records, well, we don't want them to delete them. Definitely read, definitely write, probably not execute. A web browser, well, we don't want them to be able to delete it. We just need them to execute it because it's a program that can run. So go through the table and tell me what privileges each person, each type of person should be able to do. So we've got an extension here. Try and find out how you can make a file read only or write only or execute only. How can you change the permissions of a file in Windows? How can you do the same on Linux? What's the command line things that you type in to be able to make something read only? Put your screenshots in, put your web links to show where you got your information from. And then this, please, needs to be submitted under half term 4. Yeah, here we go. There's a link on the VLE to try out different operating systems. If you want to try this out for yourself in Linux, and you can try the top one, Arch Linux. It's really small, and you can try and work out how to change the permissions. It's going really slowly for me. So you might want to research the chmod command so that you can type it in. Let's see, we'll list all the files we've got. It's going really slowly today.